So as you can see, this video is going to be about interval notation, and that's something that I would have introduced in other videos, but I thought that it may be nice to have something that's just a summary of how to use interval notation and how to recognize what it says. Okay, so this will be a summary. I try to put everything that you would know about interval notation in one place, hopefully in a way that's fairly concise. All right, so that's my plan. Let's start with this. So I'll say this is a point, okay? And when I say that this is a point, when I have two numbers, parentheses, and a comma, then you interpret that like that first number's the x and that second number's the y. And on a standard graph, like if this is the x-axis and this is the y-axis, then that would mean that I go right 2 spaces and up 4 spaces, and that's where the point 2, 4 is. All right, so that's a point. Intervals look like points. I could have that same thing. See the way that looks? Parentheses, 2 numbers, and a comma. But I could say, well, that could also be an interval depending on the context, depending on what you're trying to say or the question that you're trying to answer. Okay? Now, if I tell you this is an interval, this is not a point, then the way you understand that is that this means all the numbers between 2 and 4, but not including the 2 and the 4. Okay? That's what this would mean as an interval. So that might say, well, I'm talking about numbers like 2.1 and 3.997. You get the idea. There's lots of numbers between 2 and 4, and I'm just including all of them in that. But I'm not including the 2 and the 4. I'll say more about that in a minute. Okay? Sometimes we can compare intervals to inequalities. Okay? So let's just say generically x is our unknown number, our unspecified number. We could also write that this interval is the same thing as saying that x, our unknown as unspecified number, is bigger than 2 and less than 4. It's between 2 and 4. But if I say x is less than 4, am I including 4? Is 4 less than 4? No. So we're not including 4. And if I say x is greater than 2, am I including the 2? Is 2 greater than 2? No, so I'm not including the 2. That's why this interval says the same thing as that inequality. But people will tend to use intervals because they're a little more concise in writing than writing an inequality. All right? Okay, now I'll say more about the parentheses and so on. Let's do this. Let's talk about when we write interval notations or when we read interval notations, what are some key points? Well, parentheses in an interval notation mean that we're not going to include the number next to it. Okay? So parentheses say don't include the number. Brackets, which look like this, mean do include the number. And always, when we write interval notation, the number on the left is always smaller than the number on the right. The number on the right is always larger than the number on the left. So as we read the interval notation from left to right, that number is always smaller than this one. So those are the unbreakable rules of writing and reading interval notation. Now let's look at some examples just to tie it all together. So I thought I would match up some inequalities with the corresponding interval. So look at this one. It says x is greater than or equal to 2, and also x is less than 4. That would be this interval. All numbers between 2 and 4, including the 2, but not including the 4. The bracket includes the 2. The parentheses does not include the 4. You will find out that the brackets correspond with or equal to inequality. And the parentheses correspond to just simply less than or greater than. Okay? But if you think about it, why would we want to include the 2? Is 2 greater than or equal to 2? Well, I guess technically it is. That's kind of a funny thing to say, but 2 is greater than or equal to 2. So we need to include the 2 in our interval, okay? And is 4 less than 4? No, 4 is not less than 4, so we need to leave the 4 out, okay? So this says what? All numbers between 2 and 4, including the 2, but not including the 4, all right? What about this one? X is greater than or equal to -6, and x is also less than or equal to 10. That would be this interval. Brackets on both of them. We want to include the 6 and the 10. What about this one, though? What if I just say x is greater than 4? Well, that would be all numbers bigger than 4. The numbers never stop, right? If I wanted to say all numbers that are more than 4, which is what this says, that would be from 4 to forever, or as we say in math, 4 to infinity. Notice we have parentheses on the 4. We're not including the 4 in this statement. 4 is not greater than 4. And we always put parentheses on the infinity because there's no last number to include. Remember, brackets say we're going to include the number. Here I'm including -6. Well, if you go forever, there's like no last number to say this is it. The infinity just says, well, forever, bigger than 4. What about this one? X is less than or equal to -1. So that's like saying all numbers -1 and smaller, right? We'd have to include -1 in this statement. -1 is less than or equal to itself, and we did say that brackets would be associated with or equal to inequalities. So that would be from -infinity to -1. Remember, we always write intervals with this number being smaller than that one. This number being smaller than that one. -infinity is less than -1. That might be a little bit tricky too, so I was thinking it might help for you to imagine the number line. You know, on the number line, we got 0 right in the middle, and then we got the positive numbers to the right, and the negative numbers to the left. And, you know, I guess if the number line goes forever, and if you could actually get all the way over there, we would have infinity. And down when you go left of 0, you get the negative numbers, and that also goes forever. And I guess if you went forever over there, you get to -infinity. So when I say x is less than or equal to -1, I guess I'm talking about that. All the numbers from -infinity to -1. That's less than that. Remember, the number line goes in order. The numbers get bigger as you go that way. That's why the interval would look like that. Okay? So the interval will look like the number line. If that helps you to think of it that way, you can think of it that way. All right, so let's look at a few more examples that will give us a chance to use this. One thing that in another video I used a little bit of is when we look at a graph to identify the domain and range. And the domain is the horizontal span of the graph, the span along the x-axis, and the range is the vertical span of the graph, the span along the y-axis. So, like say that point right there, which is open, is at left 5 and down 3. Left 5, down 3. And this point, which is closed, is right 2, up 4. All right, so those are points. What's the domain and range? Well, I can see it. Like when I look at this, I feel like I can see that here's the domain, because that's the span along the x-axis, and then here's the range, right? Just roughly. Like, so I feel like I can see it, but how do I communicate it? How do I write it down? Well, okay, so it spans the x-axis from, where was this point? Left 5, okay? So that's like right there. That's -5 over to here. Where was this point again? Right 2. Okay? So it spans the x-axis from -5 to 2. All right, so I feel like I've got it. The domain, you know, now that I'm looking at it like that, is like -5, 2. Now, what do I use as far as parentheses or brackets? Is there actually a point right there on this graph where the x is -5? Oh, that point's open, so no. Is there a point where the x is -4? Yeah, it's right there. Is there a point where x is -3? Yes. -2? Yes. You like all the other numbers? Yes. But there's not a point where x is -5 because that one was left open. So we need what? A parentheses. Remember, parentheses say I'm not including this number in my statement. What about 2? We go to 2, right? But is there actually a point right there where x is 2? Yes, it's filled in, it's closed, it's there, so we want a bracket. So there's our domain. First we see it, and then we write it. What about the range? Okay, well, so it spans the graph from down here. Where was this point? This was down 3. So it's like right there, that's -3. Up to there, there's the point that's as far upward as it goes. And I didn't label that one. Let me label that one. So let's say that one is 6. That one's going to be 1 and 6. Okay? So this will be 6. Now, of course, like you would have to have either a grid or the points labeled to know this, but I labeled it for you, so there. So it spans as far down as -3 and as far up as 6. That's the span vertically. That's the span along the y-axis. Okay, so how are we going to say that then? How about, should we do 6, -3, bracket parentheses? Should we do like that? We want to include the 6, right? Because that point's there. This point where y is -3 is not. It goes like right up to like -2.9999999, but it doesn't quite get all the way down to -3. Okay, all right. Now I intentionally did something wrong there. What did I do wrong? Well, intervals are always written with the smaller number on the left and the larger number on the right. So, yeah, the answer involves those numbers. That's correct, but that's not the right way of writing it down. We want to say -3 with a parentheses, 6 with a bracket. Okay, so here's my domain, and with that intentional mistake to make a point, there's my range. Always smaller to greater. Okay, all right, let's try one more. What about this one? So I noticed this one, that point there, 0 for x, 4 for y. That's filled in, so that's a closed point. It's on the graph. Okay, there is a point on the graph up there with a y coordinate of 4, and then I notice I put arrows down there, meaning that, well, this does go forever. You know, I can't actually write it down forever because there's not enough paper, but it keeps going is what I'm saying. All right, what's the domain and range there? Well, the domain would be the span along the x-axis. Okay, so, well, like we got to use our imagination a little bit. I put those arrows, and so this keeps going, and it keeps going, and it keeps going, right? So the part of the graph I drew only spans this little portion of the x-axis, but in reality it keeps going forever, getting wider and wider and wider. So isn't it going to be like it's going to span the entire x-axis? Yeah, this graph will span the entire x-axis as it gets wider and wider. How do we say that though? How do we say the entire x-axis? Well, what's all the way to the left? If you could go forever that way, what number would you get to? Well, infinity is not really a number, but say if you go forever out there, well, negative infinity is what's all the way out there. And then if you go this way forever, positive infinity is what's all the way out there. So the domain with this graph spanning the entire x-axis is negative infinity to infinity, least to greatest. Parentheses on both, we always put parentheses on the infinities because there is no final number to include on either side. That's the domain. What about the range? Okay, well, it spans vertically. This is a little bit easier because I feel like I can say like this. Okay, it spans that part of the y-axis, going downward forever. Well, okay, so where's that point? 4? that point is up 4. Okay, but it goes forever down this way. So what's down here? Well, that's the negative part of the y-axis. So down here, like, if you could go like all the way downward on the y-axis, what's out in that direction is negative infinity. So it spans the y-axis from here up to here. So that would be negative infinity up to 4. So did I write least to greatest? Is negative infinity smaller than 4? Yeah, I mean, that's what's beyond all the negative numbers. So yes, it's least to greatest. I got the bracket around the 4 because yes, that point is there. It has a y-coordinate of 4. 4 is possible. We need to include it, but always on the infinities, positive or negative, we include a parentheses. Well, there's your domain ring. So hopefully we put it all together. Quick introduction, what interval notation is, key points, do's and don'ts, and some examples.